Hello students and welcome to the quick solution of All India Cast Test Series JEE Main 2019 Test 3 Code A and B Physics. Let's move to question number 1. In question number 1, a beam of light of intensity I is incident on a plane mirror and get reflected fully as shown in figure. The pressure exerted by a beam on the mirror is C is the speed of light. So if I consider this is a beam of area A0, then if I write the momentum of a single photon, if its momentum is P, then I can write the energy of the photon as E equal to P into C. So I can write the change in momentum of a single photon is 2p sine theta when it strikes the horizontal mirror. So if I write the total force exerted on the mirror, then F is equal to 2p sine theta into n. If I consider n is the total number of photons coming in this area A0 divided by delta T. So if I write the pressure, then pressure would be 2p sine theta into n divided by delta T into area. So if I consider this cross section area is A0, then the area of this part will be A0 by sine theta. So if I divide by this area, then this is A0 by sine theta. So from here we can calculate the pressure as 2p sine square theta into n divided by A0 into delta T. Now we have to replace the value of P and A0 and delta theta. So we know that the energy of a photon, single photon, is P into C. So if I write the total energy of the beam in area A0, that is Pc into n, and if I write the intensity I of the beam, that is energy per unit time, that is Pc into n divided by delta T. If I divide by area, then I will get the intensity. So area is A0. So from here, if I calculate the value of Pc upon A0 delta T, so that comes out to be I by C. So if I substitute this value, the pressure would be equal to 2I by C sine square theta. So option 2 is the correct answer. Let's move to question number 2. In question number 2, a photosensitive metal plate is exposed to a monochromatic light beam of frequency which is more than threshold frequency. Then plot of dn by dk versus k is best represented by, and it is given that n represents the number of photoelectrons and k is the kinetic energy of photoelectron. It means that dn by dk represents the rate of change of number of photoelectrons with respect to their kinetic energies. So we know that in the case of photoelectric effect, the kinetic energy of the ejected photoelectron is varying from 0 to kinetic energy maximum. So it will increase from 0 to some maximum value, and then further it will decrease when the kinetic energy becomes maximum. So we know that the number of photoelectrons which are ejected with 0 kinetic energy as well as the maximum kinetic energies are minimum, and in between the number of photoelectrons will increase. So if I take the rate, then the rate will be increasing initially and then it will be decreasing. So if I see the option, it says that dn by dk is 0, so that is wrong. It is continuously increasing, that is wrong. It is decreasing, again it is wrong. It is first of all increasing, reaches to a maximum and then decreasing. So option 4 is the most appropriate answer. Let's move to question number 3. In question number 3, when light of wavelength lambda is incident on a metal surface, the stopping potential is found to be V0. When light of wavelength lambda by n is incident on the same metal surface, the stopping potential is found to be n square V0. The cutoff wavelength for the metal is given by. So if I apply the photoelectric equation, that is Sc by lambda is equal to work function phi plus E into Vs. That Vs is the stopping potential. So if I put the data, then Sc by lambda is equal to work function phi plus EV naught. This is my first equation. And the second case, SC by lambda by n is equal to phi plus E times n square V naught. This is my second equation. So if I solve equation 1 and 2 for lambda naught, then lambda naught comes out to be len plus 1 divided by n into lambda. So option 2 is the correct answer. Let's move to question number 4. In question number 4, a metal surface is illuminated by light of two different wavelengths. Lambda 1 is equal to 500 nanometer and lambda 2 is equal to 620 nanometer. The maximum speed of ejected photoelectrons corresponding to these wavelengths are in the ratio 3:2. Then work function of the metal is nearly. So if I directly take the ratio of their kinetic energies, that is half m v1 square is equal to 1240 divided by wavelength, that is 500, minus 5 divided by half m v2 square, that is the maximum kinetic energy in the second case, that is equal to 1240 divided by 620 minus 5. So this is equal to ratio of v1 square upon v2 square, and this is given in the question 3 by 2 whole square. So if I solve for phi, then the value of phi comes out to be 1.6 electron volt. So option 2 is the correct answer. Let's move to question number 5. In question number 5, in a hydrogen-like atom of atomic number Z, electron is in nth Bohr orbit. The magnetic field at nucleus due to revolving electron is proportional to. So we know that the magnetic field at the center is given by mu naught upon 4 pi QV sin theta upon R square. So B is proportional to V upon R square, and from the Bohr model of hydrogen-like atom, we can write this BC as it is proportional to V, that is Z by N, and R, that is proportional to N square Z whole square. So it is proportional to 1 divided by N raised to the power 5 into Z. So let's check the options. So it is inversely proportional to N raised to the power 5. So option 4 is the correct answer. Let's move to question number 6.